All right, so now we're going to start on the new unit. It's phases of matter. We're going to start looking at the heating curves and calorimetry. So first off, phase descriptions. Yeah, so we have certain phases. We know there are four main phases. We're going to only look at three, the solid, liquid, gas. Yes, I know. Plasma is one of them, but we don't need to look at it right now. Um, by the way, just a little tidbit for you to know, there are actually more than 300 different phases. For instance, if you've ever had an oobleck, that is cornstarch and water, you will notice that it both exhibits a solid and a liquid phase at the same time. It's really, really cool. If you haven't seen it, look it up. Oobleck starts with an O. All right, so let's get back to it. Looking at volume and shape. Solids have a definite volume, definite shape. Liquids have a definite volume, no shape. No definite shape. And then gases, no definite volume, no definite shape, and they are compressible. You can swoosh them together. All right. So then you have arrangements. How are they arranged? The molecules. So solids, they are close and regular. Think of like salt. You have NaCl, and it is put next to each other in block-like arrangements. So it's close and regular. Whereas liquid, they're kind of flowy. They're still kind of close, but they're random. They don't have to be in a particular order. And then you have gas. Yeah, those are like far, far between. They do not want to be next to each other. Totally random. You don't know where anything is. Now we're looking at the motions. Solids are vibrational because they're so close together. All they can do is vibrate next to each other. Whereas liquids, they have a little bit more space in between, so they can vibrate. And along with vibrating, because they're not as close together, they can rotate in like circles. And then you have gases, which like they're so far apart from each other. They can vibrate, turn in circles, and translate. Or they can bounce off each other. They can do collisions. And last but not least, we have the forces. What forces go along or correspond with the phases? Well, strong forces, the strongest force you're going to have is in solids. You're going to find that with the ionic and metallic. And then the next one down, you got the polar covalent. Remember, one side has more pull on the electrons than the other. So that's going to be more like liquid. Think of water, where the oxygen has most of the pull as opposed to the hydrogens. And then you're going to have gases. Those are the nonpolar covalent. Think of like your Brinkelhoffs. They're diatoms. They're the same element. There's no pull to each, like more so to one side than the other. All right, change of phase. So looking at this, we have a change of phase from solid to liquid to gas. Well, how do we do that? We have a heat. We have to add heat. Well, what is heat? Heat is the transfer of kinetic energy from a hotter object to a colder object. In this case, my hotter object, that is the heat that I'm adding, like say a flame or something. A solid heated will then turn into a liquid, which heated again will turn into a gas, right? And you can kind of see those, the vibrational and almost rotational. And then here's the translational. Okay, this leads to a heating curve. Well, this plots the temperature of a sample as heat is added, starting with a solid sample below its melting point. Okay, first off, what is temperature? Let's rehash. Let's think about way back before. We said that temperature is the measure of average kinetic energy of the particle motion. In a molecule, how much do they move? What is the average movement? That will give you your temperature. And then you can add heat to it. So in this case, oh yeah, one more thing. Molecular motion stops at absolute zero. Now on Earth, we cannot reach absolute zero. That means no motion whatsoever. Why can't we reach it? Well, because the Earth is moving. We can't stop the Earth from moving, thus we can't stop motion. Okay, in space, absolutely, because there's no motion in space. But we can't on Earth. All right, So we're going to start labeling the heating curve. First off, you have this diagonal line right here. Again, solid sample below its melting point. So this is a solid. Now we're going to get to this line. This line is melting. It indicates melting is going on. During the melting phase, you have both a solid and liquid at the same time. Well, Miss Go, how does that happen? Think of when you put ice into your beverage, ice into water, ice water. You have water, the liquid, and the ice, the solid, at the same time until a point when all that solid is melted. When you get that point, you then get to see the liquid curve or the liquid angle right here. But then when you heat it enough and it gets to a certain point, it will then start here, the liquid to gas phase or phase change called vaporization. At this point, you will have both a liquid and a gas. Again, Miss Co, how does that happen? When you boil water on a stove, it doesn't go like that real quick right to gas. Nope. What happens is you get those bubbles. Those bubbles are that the water turning to a gaseous vapor. And that is why it's also called vaporization. This liquid and gas occur until all that liquid is gone, and then you finally hit the gas phase where all of it is a gas. All right. So temperature at which solid turns to a liquid, that phase change, is called melting point. When liquid goes to a gas, that is called a boiling point or vaporization point. Normal melting, this is when it normally happens, is at which point a substance melts or boils under normal conditions. But melting and boiling point can be changed by increasing or decreasing the pressure. All right. Well, let's look at my nice little table right here. Based on this table, we can figure out what is a solid at room temp, what is a liquid at room temp, and what is a gas at room temp. Well, let's look at melting. Melting at room point or room temperature should be 0. 0 is melting. So this is below 0, this is below 0, that's 0. All of these are canceled out as a solid. This 1535 degrees Celsius, way above 0. It is definitely not melting there. This has got to be a solid. All right, what's a liquid? Well, liquid, now that we've looked at melting, we're looking at liquid. So we know these three are not a solid. They have to be either a liquid or gas. How do I figure out which one's which? Go over to my boiling point. Which one has, or which one or ones have a temperature of boiling over 100 degrees Celsius, which is the boiling point for water, over here? Well, 357 or 100. Those two are definitely over 100 or at 100. Negative 196. Ooh, that 196 right there. That means, yeah, that's got to be a gas. These two have got to be a liquid. All right. Okay, so which substance can be water? 0 is melting, 100 is boiling for water. It's got to be D. Which one is mercury? Now, how do you figure that out? Go to table S real quick. In table S, look for mercury, Hg. It will show you, the numbers are just slightly off. I do apologize for that. And it's going to be right around B, right there. I think it's like 37 and 156 or 158. The numbers are off by like 1 degree. Okay? All right. So let's see. Which one's the weakest intermolecular forces? Remember, weak is gas. Which one's my gas? C. Which one's strongest? Strongest is solid. A. Which one is nonpolar? Nonpolar covalent. Those are the ones that don't have any pull towards each other. That one's going to be my gas, my C. All right. Heating curve. Ooh, let's look at this heating curve. If energy is being added over the course of a heating curve, all processes or processes are endothermic, heat absorbing. So when I'm going from a solid to a gas, all of those phase changes are endothermic, meaning I have to add heat into the system. Okay? When I do that, I'm also messing with my kinetic energy. So because I'm increasing temperature, I'm increasing movement. For pure solids, liquids, gases, phase change segments, the heat added is increasing that kinetic energy. Because I'm adding heat, I'm increasing the movement. So I'm going from all of this right here, because I'm adding heat. Anytime I add heat, I'm messing with the movement. I'm increasing the movement. So my kinetic energy is going up. But what about these flat lines? Remember, you have two types of energy. You've got kinetic and potential. When I flatten out potential energy, when my phases are changing, remember, no temp is occurring, but I'm changing phases. As I do that, you have that potential to be able to add more energy, that potential for the increase of temperature. So those are potential. The flat lines are potential, kinetics are going up. Okay, but now I have the reverse, that cooling curve. When I have that cooling curve, it is going to be exothermic. I am giving off, I'm releasing that heat. As I release that heat, my potential energy or my kinetic energy is going down. I'm becoming more organized. I'm pulling the substances, I'm making them closer together. I'm becoming more organized. Okay, cool. But because this is happening, condensation temperature is happening at the flat line instead of boiling. It's the exact opposite of the heating. All right, so instead of melting, I'm freezing or crystallizing or solidifying or fusing. Okay? All right, so here's the phase change thing. One more part of a phase change is called, my favorite, sublimation or deposition. So sublimation is a solid to a gas. You guys may have seen that in dry ice. Whereas a gas to a solid, it's kind of harder to see. We will get to see this, hopefully, in class in one of the labs. It's called deposition. It's the exact opposite of sublimation. So remember, as I'm going from solid to a gas, it is endothermic. That includes melting, evaporation, and sublimation. All of this top is endothermic. Now, on the other hand, exothermic, it is giving off heat or extreme heat going from a gas to a solid, which includes condensation, liquefaction, deposition, or freezing, solidification. Okay? With that being said, this is the end to this little section. If you have any questions, please do not hesitate to ask me. I am around. And besides that, I hope you guys have a great day.